Hey guys, good morning and thanks for joining. So we started application security. Under the application security, first part we completed already. So that is SDLC versus SSDLC. I will repeat once again what we discussed. So there are total 5 phases in the SDLC. One is requirement phase and also design phase and development phase and testing phase. Finally, release or operational phase. So each and every phase, what security team will do, part of the SSDLC life cycle. So in the requirement phase, so there are two different types of requirements. Basically, one is functional requirement, second one is non-functional requirement. So one is feature-oriented deployment, one is process-oriented requirement part. In the similar way, not only on the our development side related functional or features, even security-oriented features also it will come. Those scenarios, our security product owner will take care of the product backlog refinement. So that is also part of the requirement phase. For example, maybe in the infrastructure side, we want to implement EDR solution or whatever applications are we are developing or whatever product we are developing. So all those product logs we have to integrate it to SIM tool. For those scenarios, our security product owner has to do the analysis side and he has to do the evaluation of the different types of SIM tools and finally he has to give the solution. So even not only from the development point of view, product owner is available, even security point of view also product owner will be there. He will take care of the security feature development side. Okay, so that is on the requirement phase. So meaning here in the SSDLC life cycle, so whatever security person he is handling, one is functional and non-functional, and also along with that one security oriented feature delivery also he will take care. So that is the overall the requirement phase. In the design phase, as I said, so once the feature is going to design level, once the software architects or mobile architects or product architects, whatever they have done the design side, we should understand about what is the design is about and each and every flow from each and every component to another component. And finally, based on the Microsoft stride analysis. So nothing but spoofing, tampering, reputation, information disclosure, and finally, denial of service and elevation of privilege. According to that one, we can go and we can do threat modeling part. So we have to validate each and every component and also from the front end on the end user side and also back end on the database server side, even on the application development side, is there any flaws are existing in the design level side? We can go and we can identify the vulnerabilities and we can identify threat and we can identify the risk is involved, how much. So finally, whether they are going to accept the design or whether I want to redesign that one in the design phase itself. So that is on the design side, and whatever risk we identified, we have to raise in the risk register for tracking of the risk when they are going to fix it. In the development level, part of the CI/CD pipeline, we have two different types of scans. One is code scanning part. Second one is TPS scan, third party software scan. In the code scanning side, that is also called as static composition analysis or static application security testing. So whatever CI/CD pipeline these developers they are using, that CI/CD pipeline, different types of libraries and packages we have to install to our tools like checkmarks or Portify or Veracode or IBM AppScan, all these different types of tools. And weekly basis we have to run this scan. And the development level, is there any vulnerabilities are existing? We have to review the code and we have to write the Jira tickets and we have to track all those issues based on the criticality and severity of the respective bug. In the same development level part of the CI/CD pipeline, we have third-party software. So it's a TPS. So there are different types of commercial and open source softwares these developers they will develop at the time of the feature development. So whatever libraries and packages in the application side they are using, so we have CI/CD pipeline once again, and we have to integrate that libraries and packages of the TPS into our tools like a Blockdog or White Source or Sneak or some other tools. And we have to run this scan and we have to identify the CVID, CVSS score, vulnerability name, description, and finally solution. So then we have to write the Jira tickets to the respective development team, and they will fix those TPS issues as well, based on the compatibility and based on the performance issues. So next one on the testing phase, once the feature is going to testing side, here we will do the vulnerability assessment and penetration testing. So here this is called as a VAPT. In the vulnerabilities assessment side, if the infrastructure contains, we can use Nessus or Qualys or Rapid7, and we can run this scan. And this is applicable to not only the infrastructure, and if the application is deploying in the cloud side, and we have to run the cloud scans as well. And also in the second phase is the DAST, dynamic application security testing, and we have to do the automated tool scanning and identify the vulnerabilities. And based on the severity, we have to raise once again the JIRA tickets, and we have to track all those tickets by assigning the tickets to either design team and development team and testing team. And penetration testing side, we have manual and automated. As I said, automated is dashed dynamic application security testing, and also manual is we have to launch the application, or we have to launch the mobile, or we have to launch the product, and finally we have to run the couple of commercial tools like burp suite or wasp or postman and other tools, and we have to identify the pen test results. Is there any vulnerabilities can be attacker can be exploited, and based on the severity, we have to raise the JIRA tickets once again, and finally we have to assign to either design or development or testing level. They will fix those issues based on the whatever patch policy we are using. So patch policy, once again, not only on the vulnerability management side, whatever we discussed in the vulnerability management part of the infrastructure security, even for application security, product security, mobile security, OT or IoT security also, patch policy we have to define. So respect to security team and also respective application developers, we have to sit together, and finally we have to fix the patch policy, whether they want to fix critical vulnerabilities in the 10 working days, or whether they want to work in the 3 weeks time period, and high, medium, low, and also informational side. So according to the patch policy, whatever we define, this patch policy GRC team regularly they will update by contacting the our application developers and also our application security team. Okay, so that is patch policy point of view. And finally, once the security sign up is completed by the respective security team, then that feature will go to the production environment or release or general availability. Now public can access that particular feature. There are several teams are involved for one feature development or one product development or one mobile development. So that may be example product PO, development master, scrum master, DevOps team, TechOps team, SecOps team, DevSecOps team, and also site reliability engineer team, and finally security team. These many teams are involved to deliver one of the feature. So that may be either on the application side or product side or mobile side or OT or IoT side. Okay. So patch policy, I will give example, whatever we followed in my ex company. So whenever any critical vulnerabilities or critical bugs or critical code scanning related issues are occurred, so we have to fix in the 2 weeks time period, nothing but here 15 days, 10 actually 10 business days, 10 working days. Next one is on the high side, high vulnerabilities. It's 30 days or 1 month. It's a medium or low and info level. Respect to developers or testers, they have to fix in 3 months. So as I said, it's not a mandatory every organization has to follow this policy. As said previously also, it depends on the whatever application developers and product developers versus security, how they are fixing. So we have changed this several times the patch policy also. So initially we given only 1 week, but the developers were not able to fix in the 1 week time period. So because they have to do the testing as well. So that is the reason later we change it to, so 10 working days, that is almost equal to 15 days, because 4 days will go to even weekend as well. So that is the patch policy we followed. So that is about overall SSDLC life cycle. Now coming back here, we will go to second topic under the application security, cryptography. So what is this cryptography? is one of the important topic from the interview point of view, not only from the interview point of view, even for the especially on the data terrestrial and data transit level, we can use regularly this topic. So cryptography mainly it will represent cryptocurrency is different, that is digital currency. And coming back to here cryptography, say cryptography side, what we can exactly we will use. So here it can be provide secure way of web communication or secure way of the communication using mathematical calculations and also using the couple of the algorithms. And finally, so attack it's difficult to hack the data. So that is called cryptography. So here secure way of the web communication, secure way of the any communication, it's going via data at rest level or data at transit level. So how we can define this one? Secure way of web communication using mathematical calculations and also cryptography algorithms or algorithms. So we can encrypt the data and the attacker, it's difficult to decipher or decrypt the data. So here we will use for that one couple of keys. There are two different types of keys we can use. For this one example is encryption and decryption. So here mathematical calculations we will use and also algorithms we will use, computer algorithms we will use. So we are going to discuss part of the symmetric and asymmetric. There I can show how the mathematical calculation it will appear and how the cryptography algorithms it will appear. Okay. So, but in simple words, it's a secure way of the communication. It will provide encryption. It will provide integrity. It will provide confidentiality. It will provide non-reputation. It will provide the traceability as well. So these things can be provided by our cryptography technology. Now, example of the cryptography. First one is encryption and second one is decryption. So already we know what is encryption and what is decryption. Encryption just providing the password or key. So that is called encryption, and decryption is opposite. So whatever encryption we are doing, we have to decrypt using the keys. So here we will use two different types of keys. Those keys are for encrypting the data and decrypting of the data. We will use two keys. Those keys are normally cryptography side. One is the primary key, sorry, private key. So this also called secret key. Second one is called public key. It's a shareable one. So these two keys we can use for the cryptography side. One is private key. So private key we cannot share with the other people. So that's why this is called a secret key. So we can have to keep it ourselves. And second is called public key. So public. So everybody can use it. So that's why we can call it, this one is shareable key. Okay, we can share with others as well. Now under the cryptography side, we have three different types of cryptography technologies. Cryptography algorithms are, one is symmetric, hybrid. So this also called as PKI, public key infrastructure. Now what is symmetric and what is asymmetric and hybrid? What is hybrid and what is SSL TLS mutual authentication or SSL TLS negotiations? We can discuss now one by one. First one is symmetric cryptography. So symmetric cryptography, symmetric, it's a meaning here same. So same key used for both encryption and decryption. So that is called symmetric cryptography. So for example, maybe whenever any debit card or credit card statement or other card, if you want to download, so respect to banks, they will encrypt and using our postal letter, 4 letters of our name, along with month and date, we can download. So whatever that one they are doing, that is called as a encryption, and whatever we are downloading the bank statement, we can call decryption part. So here same key we are using for both encryption and decryption. Otherwise, I can give one more example in our technology oriented example, endpoint encryption or database encryption. So under the endpoint encryption, we discussed about encryption using agent based. So for every laptop or every MacBook or workstation or desktop or servers, we can provide the encryption part. So whatever encryption we are doing, so that encryption we can call it as a same key we are using for both encryption as well as decryption. So that is called symmetric. If two different types of keys we are using, that is called asymmetric side. So that is nothing but my private or public. So let's go and see now here what are the other differences are there part of the symmetric here. And one more thing I want to clarify. So these data at the rest level of the encryption and data at the transit level of the encryption. What is data at the rest level of the encryption and data at the transit level of the encryption? If the data is not moving and data is a fixed one, that is called data at the transit level. For example, endpoint encryption. For example, server disk encryption or database encryption. All these will fall under the data at the rest level of the encryption. Then what is data at the transit level of the encryption? So in the transfer level, if you are encrypting the data or if you are decrypting the data, that is called data at the transit level. For example, these scenarios we can use any secure way of web communication or accessing any web browser. That is one of the practical scenario. Or if you are connecting VPN, that may be remote VPN or site-to-site VPN. So there also we can use this data at the transit level of the encryption. Even we can use on the email side. If the mail is sending and if the mail is receiving using SPF, DKIM and DMARC, so mail should be encrypted. So that is also data at the transit level encryption. And if you want to access RDP server, like a Windows machine, so using RDP connectivity, there also we can use this data at the transit level of the encryption. So in the transfer level, if you're encrypting the any data, that is called data at the transit level of the encryption. And if the data at a rest position or fixed position or static position, that one we can call it as data at a rest level of the encryption. That is our encryption types. Now, what is symmetric here? So as I said, same key used for both encryption and decryption. Example or door key. So even whatever door we are locking and unlocking, we are locking and unlocking with the same key. So that is our day-to-day life example. Is called as symmetric cryptography. So what symmetric cryptography advantages now? So example, as I said, so endpoint encryption. So let's think about voice encryption here, whatever we discussed under the endpoint security. And also disk encryption and also database encryption. So now what are the advantages of the symmetric cryptography? So it will provide confidentiality because we are encrypting the data. It will provide confidentiality or privacy, and it will provide encryption. So these two things only it will provided by advantage of the symmetric side. It will provide the confidentiality and it will provide the encryption. And what is one more advantage here? It's a faster. because same key we are using for both encryption and decryption. So that's why it is a faster one. So now, what are the drawbacks of the or disadvantages of symmetric? So drawbacks side here, it will not provide any authenticity, authorization, and also it will not provide any integrity, and also it will provide non-reputation, traceability, something in attack it's happened. So that is the drawback here. It will not provide any authenticity and also integrity and non-repudiation. So that is one of the drawback. So second thing is it will use more number of keys. So what is the formula as per the mathematical calculations these scientists is invented for the symmetric cryptography side is n into n minus 1 by 2 for n number of keys. Formula equals to n into n minus 1 by 2. So this is based on the probability side. In the 10th standard, we studied about probability and statistics. PNR equals to P factorial by n minus R factorial into R factorial. So that is the way how this formula is appeared. So here for a number of the keys, what is the formula these scientists is invented? It's n into n minus 1 by 2. And now, what are the examples of the, so here, instead of the n place, you can substitute any of the number, then you'll come to know how many number of keys will be exchanged. So for example, in the n place, we are putting 10 as a n equals to 10, 10 into 10 minus 1 by 2. That will come approximate 45, not approximate, that will come as a 45. So those many keys are required for the symmetric side. Now coming back here, it will use the out of keys band exchange, more number of the keys. It will use more number of keys for exchange. So those are all the drawbacks or disadvantages on the symmetric side. Now example algorithms are, what are the example algorithms these scientists is invented part of our symmetric side? RC4. So RC4 is one of the scientist name. That scientist name is called Rivest. And C4 is a version control. So whatever symmetric side we are using almost less than 256 bits. So remaining all are more than 512, I mean 256 more than. So all these are less than 256 bits only. So second one, once again, he identified or invented one more algorithm, that is RC5. In the similar way, Mars is another symmetric cryptography algorithm. And also we have two fish. This is another algorithm. And also we have blowfish. This is another algorithm. In the similar way, we have DES, data encryption standard, AES, advanced encryption standard, and also 3 AES. It's a little bit advanced standard once again. Advanced encryption standard. So these are the couple of the algorithms. There are so many, more than 50 to 100 in between. These many algorithms are there. Okay. If you are going for CASSP, Shiva, you can call me after this call around 9 o'clock. So we can discuss. Yeah. So if you are going for CASSP book, so we have more than 50 algorithms are there as per the symmetric and asymmetric side. Okay. So these are the couple of the algorithms. In case if you want to use the symmetric side itself, so which one we have to use? Either we can use a DES or AES or 3 AES. Why? Because so it will support 128 bit and it will support 128 bit and 256 bit. and it will support 256 bit. So remaining are less than 128, like 32 or 16 or 64 or 48. So those are all legacy. Attacker can guess the key or password easy way. So that is the reason these are outdated or legacy. So we should not use those legacy or outdated cryptography algorithms. We have to use strong ciphers or strong cryptography algorithms. So we discussed about a couple of attacks like Sweet 32 and also Podal attack and also OpenSSL bleed attack. All those are because of these issues only. In case if we are using the weak ciphers or weak algorithms in our SLTLS certificate side or in our self-signed certificate side, so attacker can guess that bit easily, like it's similar to equivalent to our strong password policies and plain text password policies. That is the difference in simple words. So these are all on the symmetric side. So now same way we can go and we can discuss about asymmetric side, asymmetric cryptography. Later I can provide the tabular format. What is symmetric versus asymmetric? So as I said, asymmetric, it will provide the two different types of keys for both encryption and decryption. So that is called asymmetric here. One is for public key, two different types keys, meaning one is public key and one is private key. So two different keys can be used for encryption and decryption is called as asymmetric. Now, what are those two asymmetric keys here? One is public key and private key. And here keys will be exchanged in between. So client and server or peer-to-peer devices in such a way encryption channel it will provide. Coming back here, what are the different types of advantages it has? Advantages. It provides confidentiality. It provides authenticity. It will provide authorization using digital signature. So authenticity from the end user point of view, non-reputation, and finally it will provide integrity as well. But these things cannot be performed by our symmetric. Okay, so because keys are not exchanged and we are not using any digital signature on the asymmetric side, only we are encrypting the data, that is on the symmetric side. But here negotiations will happen. So like a client and server or peer-to-peer devices, negotiations will happen. So that's what will provide about these parameters, everything. So that's why as compared to symmetric, always asymmetric is better. Okay, so these are all the advantages. Now what are the disadvantages here? So disadvantages here, disadvantages of the asymmetric. It is slower. Yeah, that is the only one drawback here. Otherwise, everything is fine. So now coming back, what are the different types algorithms are supporting by asymmetric one? Example algorithms. So these are all very important guys. Example algorithms. So one is DH, Diffie-Hellman. Is a scientist name. He invented the Diffie-Hellman algorithm, DH algorithm. And here it will support about 512, 1024 bit number, 2048, and most recent one is 4096 also. These many bits it will be supported by our Diffie-Hellman. Bit size is very high and it's difficult to uh, guess the respective key by the attacker. So second one is we have the ECC, elliptical curve cryptography. So this is like a hyperbola and a parabola combination. We can call it as a like a eclipse. So eclipse and hyperbola, if we are mixing together, we will call it elliptical curve cryptography here. So this is also one of the scientists is invented. So this also will support about all these firewall 1024 and 2048 and 4096. And next one is we have RSA. So RSA full form is not RSA company. RSA we have company also part of the EMC Square. Okay, RSA Security otherwise company that is acquired by EMC Square now. It's a part of Dell once again. So this RSA algorithm is invented by three people. So first person name is called Rivest, and second person name is called Shamir, and third person name is called Edelman. So these three people is invented algorithm. So first three letters of their name, they given the algorithm as RSA, and it will support once again firewall on 2048 and 4096. And we have DSA, digital signature algorithm. So same thing here, it will support for all these four strongest ciphers. And finally, we have knapsack. So this also will support all these four different types of strongest ciphers. So these are all the examples on the asymmetric side. So now, which cryptography algorithm is better? Asymmetric side. Now coming back here once again. So what are the advantages and disadvantages and what are the features point of view? I can explain in the tabular format, and this tabular format is important from the interview point of view. So let's go and see what are we discussed. Just I can make it like a summary. And here symmetric side and left and right hand side is asymmetric side. And if we're mixing these two, we can call it as hybrid cryptography. So hybrid cryptography is also called a PK, public infrastructure. There we can use a part of the SSL TLS mutual authentication or SSL TLS negotiation part. So symmetric cryptography and asymmetric cryptography. So what is the first point we discussed? Same key used for both encryption and decryption. Second point, what we discussed about it will provide confidentiality. So third point we discussed about is faster because same key we are using for both encryption and decryption. And it will use out of keys band exchange or out of number of the keys. It will use more number of keys. And also for a number of keys, formula equals to n into n minus 1 by 2. So these are all and example algorithms what we discussed now. So we discussed about RC4, we discussed about RC5, we discussed about two fish, we discussed about blowfish and also Mars. Then we have AES, 3 AES, DES. In case on the symmetric side, if you want to use any algorithm, we have to go with the either DES or AES or 3 AES. So in the SLTLS certificate also, we can see the combination also. Combination meaning here, give me some time. Here, first point is, it will use two different types of keys. For encryption and decryption. And here, it will provide confidentiality, authenticity from the end user, integrity, because we are using SLTLS certificate using digital signature algorithm, non-repetition, something it is happening, traceability using logs. We can go and we can verify. Authorization can be done by backend server. Okay, so it will provide all these parameters. So it, as compared to asymmetric has a more advantages, and it is slower. Next one, it will use less number of keys. And formula for n number of keys is equals to 2n. So this is the formula. Now example algorithms already we discussed. So one is RSA, second one is DSA, digital signature algorithm, and third one is Diffie-Hellman. Fourth one is knapsack. Next one is ECC, elliptical curve cryptography. Yeah. So these are all the couple of algorithms on the asymmetric side. So this one of the very popular interview question: what is the difference between symmetric and asymmetric? Otherwise, they will ask what is symmetric and what is asymmetric. So whenever they will ask some of the questions, you have to give these overall answer. So now most of our certificates, whatever we are using, part of the SLTLS, it's a combination of both. Mixer also we can use, like a hybrid. So we can use the combination like a DES plus a RSA plus DH. In the similar way, we can use AES and also RSA, and also we can use 3 AES. In such a way, hybrid also we can use it. So what is the compliance we will follow for any certificate side? We will use one of the compliance. For choosing the correct ciphers, either it is weak or strong, we will use compliance name is called as PIPS 140-2. So this is the complaints. We can discuss this one under the GRC once again. What is this PIPS 140-2? For example, maybe application developer is coming and he's asking like, we want to deploy one of the certificate on top of the website, whatever we are going to build up. In the similar way, on the SCA's hardening benchmark, we are running JNSCAN on the OS level or endpoint level, cloud level or database level. As I said, we will get sweet 32 vulnerabilities or weak ciphers information. So how can you provide the strongest ciphers information to the respective either server team or database team or application developer or product developers based on which complaints? So we will follow one of the complaints. That complaints is called as PIPS 140-2. What is the practical use case this scenario? So we have to go and we have to verify which one is weak ciphers and which one is strong ciphers. That is our validity. So security team has to do validity that one. Even in the certificate side also, whenever we are purchasing the certificate, what is the hashing algorithm, whether it is the strongest algorithm or weakest algorithm. In the similar, what are the different types of symmetric and asymmetric cryptographies it is used. Those verifications we can do. And one more thing is certificate expiry and renewal of the certificate also. So that is on the website side. And even on the OS level and database level, once we are running the, so either any hardening benchmark or maybe either normal OS scan or database scan or endpoint scan or cloud scan. So part of the vulnerability management. So yesterday we discussed all, not yesterday, 2 days back we discussed about a couple of example vulnerabilities like SL certificate cannot be trusted, and also TLS version 1.0 is detected, SL 1.0, 2.0, 3.0 is detected. In the similar way, self-signed certificate you are using. So Sweet 32. So these are the couple of the vulnerabilities, it will appear in the vulnerability report. Those scenarios also, if we want the mitigation, so which is the complaints we have to follow? We have to follow PIPS 140-2. So this is like a Bible to us. We can go and we can verify and we can validate and we can provide the strongest information to the respective internal stakeholder. Okay, now what is this PIPS 140-2 full form? Federated Information Processing Standard. So Federated Information Processing Standard 140-2. So that is the overall, okay, so full form of the PIPS 140, they given the number. So we have 140-1, 140-3 also there. So 140-3 is like advanced one, and 140-1 it's like a legacy one. So these are all the different one, but we can use 140-2 or 140-3. So that is of the standard we can use. This is a part of our GRC compliance, like a PCI DSS or HIPAA compliance or CS auditing benchmark or voice top 10. This is also one of the complaints we have to follow, especially to identify the or validating of the ciphers information whenever we are purchasing on the application, I mean certificate side. Not on that one, even on the infrastructure network side, is there any OS, SSL or TLS oriented vulnerabilities are existing? Then we can go and we can verify. So not only that one more practical use case is CS hardening benchmark. So as per CS hardening benchmark also, so one of the hardening benchmark it is belongs to, we have to use the strongest ciphers as compared to weak ciphers. So that is the complaints name. Now, what is hybrid cryptography? Third one. So hybrid cryptography is a combination of both symmetric and asymmetric. So what is this hybrid symmetric and asymmetric? So we can use both the combinations. As I said previously also, whenever we are purchasing SLTL certificate, it contains both the combinations also. We can use these three. So AES, 3S and DES along with the combinations like we can use other combinations like a Diffie-Hellman or RSA or ECC or knapsack or DSA. So these are all the algorithms also we can use it. Okay. Now, what is the importance of the symmetric and what is the importance of the asymmetric side? So symmetric cryptography can be used for data transfer. And asymmetric cryptography or asymmetric keys used for the key exchange. So data transfer, for example, I want to transfer X amount of money to my family. In that scenario, I can log into respective either net banking or through wire transfer or maybe through our PhonePe or Google Pay. So for example, maybe through net banking, I'm transferring. So then I will go and I will log in. I will provide my username and also I'll provide the so password and multi-factor authentication. Thereafter, I will select the respective beneficiary and I will select the amount. Finally, I will submit once the multi-factor authentication is successful. So this is the way how I can transfer the money. Wherever you are entering the data, so there it is provided confidentiality of the end user using the encryption side. So for example, username, password, and also beneficiary name, and also X amount of the money, and also OTP. All these cases we can use for the data transfer. Those data, whatever we are entering, so that is asymmetric side. And asymmetric side, keys exchange in between our front end user to back end server. So example, take ICICI Bank, or Citibank, or Axis Bank, or HSBC Bank. In that scenario, back end server to our front end user, keys will be exchanged. So that can be done by asymmetric side. For data transfer side, we can use the symmetric side, what our data we are entering, and also asymmetric side we can use for the keys exchange. So not only that one, even example through VPN tunnel. Maybe you are transferring some of the VPN through remote VPN, you want to access your office application, or maybe through remote application after accessing that one, first it will form a tunnel. So whatever tunnel it is forming in between your home location to the respective office location, so it will exchange the keys. There we can use the asymmetric side, and whatever data you are accessing and whatever applications you are accessing in the on-premise or where the data center is located, so that is part of the symmetric side. So this applicable to side VPN also. In between two firewalls or in between one VPN server to another VPN server. So if you want to create any VPN tunnel, so we can use IKE phase 1 and IKE phase 2. So here in between firewall 1 or one side to another side, keys will be exchanged. So whatever data you're trying to access from one side to another side, there symmetric keys we can use. So not only that one, example on the email side. So we are getting one of the email. So sender is sending the email to us and we are receiving the data. So in between sender and recipient, we can exchange the keys through SMTP server or through email gateway. That is called as a DKIM, domain key identification message. So here that keys will be exchanged. We can using the asymmetric side. And what is the body of the content of the payload we are using part of the drafting an email. So that is called as so symmetric side. So this is the way how the practical use cases we can use and we can apply for these symmetric and asymmetric side. Okay, so let's go and discuss about now SSL TLS mutual authentication, or this also called as SSL TLS handshake. How this will work? So whatever I given couple of examples now, all these places we can use these SSL TLS handshake or mutual authentication side. For this one, so take this one is example client or end user. So on the front end, so here backend server. Now in between these two, how the exchange will happen? So example, as I said previously, PhonePe for using you are transferring some of the X amount of money to your family or maybe through net banking side. So first you will go and you will initiate the connection. So nothing but here, end user will log in or initiate the connection. So through web browser. So after that, what will happen? So end user, first step, end user will initiate the connection in the web browser. Example, www.hdfcbank.com, hdfcnetbanking.com, whatever. So after that, what will happen? So now, so every client also has a two keys and server also has two keys. So private key, we should not share it. Only public key, we can share it. So here two keys can be maintained by our server. One is called public key and second one is called private key. And here also public key and private key. Now, so what is the second step here? So once the end user initiating the connection through any web browser, what a website he wants to access, now backend server, it can share the public key to end user. Okay. So now server will send public key to end user or client. So that is the second step, because public is a shareable key. So private key we should not share it. Now, so in the third step, so symmetric. Now I logged into HDFC Bank. Now whatever data I'm entering here, otherwise Facebook you can take. So now I given facebook.com as a example here. So when I initiated the connection, so that is the first step. Now Facebook server is responded back public key to me. So using that public key, I have to encrypt the data. So now whatever data I'm entering, so for example, take mobile number, whatever, or maybe email. So these are all plain text data. So these plain text data we have to encrypt. So for that one, we have to use one of the key. That key is sending by our server to us. So that is shareable key now. Okay. Along with that one, so data, this is data. Now, whatever I am providing input validation, part of the application side, it's a data. So it's a mobile number also data, even email address also data. So this is also one of the data. So these two. So in the third and fourth step side, symmetric KSP can be used for data transfer, whatever end user is providing input validation. In the second step, already we have seen, so public key is sent by our, backend server. Using that public key, what end user will do now, whatever public key is shared by server, end user will use that public key and he will encrypt the data. So that is the way how the encryption it will happen. Now, finally, encryption channel it will form in between client and server. Finally, so server has its a private key. Server has a private key. So using that private key, it will decrypt the data and finally it will see what is the end user is responded back. It will see what the end user is send it back. What he needs, example. He wants to transfer the money. So that request will go using HTTP request and also through HTTP response using HTTP 2.0 protocol using get and post request. So now using the server private key, server it will decrypt and it will take appropriate actions. So this is the way how the overall data can be transferred in between client and server. Now I have one question in this overall 6 steps. So here end user is providing the authenticity. So here end user is providing the username and password. So it is providing the authenticity. And using the keys, we are encrypting the data and we are sending. It is providing the confidentiality. So it will provide privacy of the data or secrecy of the data. And whenever any attack is happening, who has done what? Because his end user is logging. So that is called non-reputation or traceability. And also finally, authenticity, authorization. Authorization is verifying the backend server to give the grants or permission whether the end user is there or not in the backend server. So that is the reason. So using these two different types of combinations of the symmetric and asymmetrics, we can do the SLTLS handshake. Now I have one question. Out of all the 6 steps, which one is drawback it contains, or which is disadvantage step it contains? Anyone? One of the step contains the drawback. What is the drawback?
Second one, I think.
Second one. What is the reason, Nagarjuna?
Maybe the attacker can also provide the key to the end user.
Okay.
Uh,
Can you give the
instead,
couple of practical techniques? How the issue it will happen? You are right. You are
like
absolutely right.
Kerberos, that golden silver ticket attack.
Okay. Silver ticket attack. Okay. Silver ticket attack. It's mainly for the on the Active Directory side, but this is not on the Active Directory. This on the application side.
Middleman attack.
Man in the middle attack. Okay, perfect. Man in the middle attack on the so application side. Okay, what is the another option? Session hijacking. Okay, what is third option? Third option is so token based JW token. So this one we are going to discuss under the WASP top 10. So we have opened it. So on the application side, what are the authentication mechanism? First of all, we can use the SAML authentication. This one I explained long back. I'm not sure whether you remembered or not. When we discussed about cybersecurity definition, on the endpoint side, if you want to log into either laptop or MacBook or workstation or desktop, we can use the authentication mechanisms are SAML authentication mechanism, NTLM authentication mechanism, Kerberos authentication mechanism. That is on the endpoint side. So next one on the network side. So if you want to use firewall or proxy or network IDS, network IPS, as per Cisco terminology, we can use Radius server or Texas server. So these two servers on the network side authentications. Remote access dial-in user authentication and Texas is another way of the authentication. So that is on network side. And if you want to access the authentication on the application side, we have SAML authentication and we have OpenID connect with OAuth 2.0 protocol. Along with that one, we have JW token based. For every session, whatever it is establishing, so it will form a token. The token, it has to disappear once the end user is logged out, once the session expiry is going out. Okay, so using the URL manipulation or taking into deface or fake website or URL redirection or maybe through session hijacking or maybe through man in the middle attack or maybe through stealing of the token, attacker can take into the deface or fake website. Then on behalf of the server, attacker will send the public key to end user. Now, once the end user has taken that public key, is sending and he's taking to that particular thing, then it will go to attacker website, not onto the so this particular whatever legitimate website we are trying to access. So I'm repeating once again, what are the possible ways attacker can use these keys and sending to the attacker? One is the man in the middle attack, a session hijacking, stealing of the token in the URL site, and also URL redirection and URL manipulation and taking into deface or fake website. Now, if we want to mitigate this drawback, what we have to do? Okay, we identified drawback is there in the second step. We identified that is drawback. So we are not sure whether legitimate server is responding back to the end user or else attacker is responding back on behalf of the backend server. So that key is whatever it is sharing. Now, if we want to mitigate this one, what we have to do? Any idea?
You have to use digital certificate.
Yes, we have to use SSL TLS certificates. So that is where it's a digital signature algorithm concept and digital certificates, it will come into picture. So before going to digital certificates, now what is the drawback here? Drawback is there part of second step. We are not sure public key is shared by an attacker or legitimate server. If you want to eliminate the drawback, who is sending the key, we can use digital certificates or SLTLS certificates. Now, this digital certificate, how it will provide about, okay, so authenticity and also integrity and non-repudiation. We can see that one. Before going to that one, part of the digital certificates, first I have to explain about integrity. So integrity is depending on what are the different types of parameters. So what is integrity? Anyone? What is integrity? We discussed already long back part of the ctreated confidentiality, integrity, and availability. So what is integrity?
Data manipulation.
Trustworthy of the data.
Yeah, trustworthy of the data in simple word,
Yeah.
or secrecy of the data, or otherwise unauthorized attacker or end user cannot add or delete or modify the data. That may be data manipulations he should not do. So that is called integrity. Data manipulations are unauthorized user or attacker should not add or delete or modify or update the data. So that is called integrity here now. So how the data can be manipulated, how the data can be modified. So based on the what parameter, data can be modified in two ways. One is knowingly, wantedly they will do. So example, our internal user, even though he does not have the access to, for example, finance related reports, he will try to access those reports. So, but because already we are using the file permissions in the OneDrive or maybe Google Drive or file server, he cannot access. Otherwise, if the access he contains, obviously he can go and he can change or he can modify the data or he can delete the data also. So that is one of the example. Even in the server, if the administrative access everyone has, maybe he will delete the existing user accounts or he will create new accounts or he can delete the files or he can do whatever he wants. Example, rootkit attack or privilege escalation attack. So one is knowingly, so people will do. Second one is unknowingly. So data can be manipulated or data can be modified. So this is also called intentionally, knowingly or intentionally, unknowingly or unintentionally. So this is the way how the data can be modified without knowing us. So couple of times mistakes will happen if you have the full-fledged access. So this is the way how the data can be modified. Now, integrity is depending on several parameters. Integrity is depending on first thing is hashing algorithm. Second one is HMAC. Third one is digital certificates. So these are the three factors basically integrity is depending on. Now, what is hashing algorithm? What is HMAC? What is digital certificates? Can we continue or can we see tomorrow? Can we see evening? Shall we continue or shall we see evening?
Sir, if you have time, you can.
Yeah, I have time, but couple of people has to log in. That's why. Sai, Karthik, Nagarjuna, these people. Okay, no problem. We can continue evening class because already it's 8:55. So it's better I can take 7:30 to 8:30 morning, and evening I will take the class from 6:30 to 7:30 p.m. IST. Okay.
Sir,
So
one thing, sir.
yeah, please.
Sir, how we will know that like how to analyze this kind of man in the middle attack, like browser based, how it is
Yeah,
compromised, how we can know like
yeah, that is the reason we can do penetration
analyzing
test.
part.
Yeah, analyzing part we can do logs integration. So whatever logs are generating part of our end user side, or maybe attack is trying to do on behalf of the end user, like session hijacking and man in the middle attack. So those logs on the application side, and also backend database logs, and also web application firewall logs, and also backend server where the web server is hosted on top of the web server. So using these logs, if we are integrating to SIM tool, and we can create a couple of the correlation rules. So what are the correlation rules we have to create? We have to create all the correlation rule for WASP top 10 category of the attack. So whenever attacker is trying to do these category of the attacks now, so automatically those logs, it will go to our SIM tool, and event collector or log collector, it will collect the logs. Then log manager, it will do the processing of the logs. And based on the correlation rule and based on the policy, based on the condition, whatever we are defining, so it will hit that logic or condition or algorithm, and finally alert will be triggered. Once the alert is triggered, whenever the attacker is trying to do or the internal employee is trying to do, as a SOC team with the collaboration of the application development team, we have to go and we have to analyze whether really attacker has done, or it is a legitimate or illegitimate, it's a false positive or true positive. So this is the way how we can analyze. Is it clear?
Yes, sir. Hello,
Yeah, please.
sir. Which all devices will can detect this and how can we protect online? Like
Yeah, we
antivirus or EDR, which will
no.
protect it and
Antivirus is not on the application side. So we can use the either third party federated identity when the end user is accessing, or single sign-on solution like a zero trust network access, that is called ZTNA. That is the authentication side. On the application side, we can use web application firewall. On the backend database server, we can use database encryption. So these are all the couple of things we have to implement so that we can go and we can analyze whenever this category of the attack it's happened. Coming back to your question, as I said, so we have ForgeRock, one of the third-party identity tool. In the similar, we have AWS Identity and Access Management, and also we have Azure Identity and Access Management. We have PAM solutions, and also we have single sign-on solutions like a Okta or Microsoft Identity. These are on the front-end user side identity. So in the similar way, whatever OS top 10 we are configuring, part of all these top 10 category of the attacks or SANS top 25, for each and every attack, so we have to define the rule or condition or policy based on the signature and based on the either machine learning capability for unknown category side, alerts will be triggered or logs will be generated. So that is web application firewall is one of the tool. So obviously SIM tool is another tool, and database activity monitoring is another tool. So these are the couple of tools we have to use.
and which device will detect this IDS, IPS, or which will detect the
IDS it will not detect. IDS it's because not the network. It is not a network activity. It's application activity. As I said, next generation firewall it's a capability, and also web application firewall is a capability, and also we have, as I said, identity side is another third party. So our single sign-on or JTNA related tools. So on the database side, we have database monitoring tool. And to centralized overall analysis, we can use SIM tool. So IDS IPS will not do that.
Okay, sir. Thank you.
Welcome. Any other?
Artem, where we will be using this asymmetric case? I know the symmetric we use AES 256,
Yeah.
but
So
the
we can use mixer. Basically, most of the applications they will use a combination of both symmetric and asymmetric. So example, you can go here and check the connection is secure. and certificate is valid. And you can see public key. This is the key shareable one. This is the key shareable one. This is the key shared by the respective backend server when the end user is accessing. Okay, using this key only, whatever data right now I'm entering, either phone number or maybe, first thing is I have to verify whenever I'm logging to any application site. So here domain name or common name is basically coming from the end user site, sorry, legitimate website or illegitimate website. Facebook.com, it's a legitimate, and I've opened the Facebook.com, it is matching. If the attacker website common name or fully qualified domain name or the domain name where he purchased the certificate, so obviously it is different, obviously. So we cannot trust that one. And coming back, so here they purchase this particular certificate from the DigiSet. And what is the hashing algorithm they are using? SHA-256 to maintain the integrity side. So that is today evening topic. And the public key is a shareable one. This key is shared by the Facebook to respective end user. Okay. So this is certificate. And if are going to details here, certificate signature, this is the serial number version here. So version TLS 1.3 and serial number. This is the serial number of the certificate. And here certificate signature algorithm RSA with SHA-256. So it is using asymmetric. As I said, this one couple of times we can use combination of the symmetric and asymmetric also. Right now, Facebook is using RSA. Is it
What
clear?
is that asterisk refer to?
PKCS, it's a format basically. PKCS
No,
is a
the
format.
asterisk I'm saying. Asterisk facebook.com.
Asterisk
The
is
star.
mainly for the domain. Whenever we are giving the domain name, asterisk it can represent about the dedicated legitimate website or not. Okay, so this is the way we can validate our, even we can validate one more thing is when the certificate is going to expire. So certificate expiry is November 12th, within 8 days. So the certificate is going to expire and Facebook has to renew the certificate before November 12th. So otherwise, in case they forgot, forgot to renew the certificate, so obviously encryption, integrity, authenticity, authorization, complete end of life and end of support, attacker will try to do the hacking side. So they can fix this particular issue by before November 12th. I think within the next week they will complete. Any other?
Sir,
Okay,
I
then
have one doubt.
yeah, please.
Hello.
Sir, if we want to transfer more data,
Hmm.
how can we do this encryption of this?
Through web browser?
Uh, yes.
No, I didn't get your question. So through web browser, if you want to upload any data, obviously we can use either OneDrive or Google Drive. So those scenarios through SFTP, if you are to send it, so once again depending on whether single location, distributed location. If single location through file oriented, if you want to send the data, obviously we have to use SFTP protocol, copying of the one file from another file. And if you want to send from one location to another location, in that scenario, we can use VPN connectivity.
Okay.
Yeah,
Hello, sir.
yeah, please.
Sir, any two scenarios can you give in the evening, like for this man in the middle or session?
No, that is, we will
How is
discuss part of WASP top 10 because it's not completed yet. So we did
okay.
not discuss the WASP top 10. That one I'm going to explain under the WASP top 10. That is tomorrow topic.
Okay.
Yeah. Okay, guys, then see you evening at 6:30 p.m. IST. Have a great day.
Okay, can I reach you?
Yeah, you can call me now. Yeah, sure.